All right, just making sure. All right, hey everyone, my name is Rob Thielen. I'm CEO and co-founder of Round and co-founder of Llama Farm. And today we're going to have a fun presentation about different types of models. So everyone here knows about the like popular models right now. These LLMs, they are in the news all the time. Everyone's using them. Everyone's coding with them. These large language models that you see with ChatGPT and Gemini, and they're popular and cool. But I'm going to talk about today how you're probably misusing them and how there's other models in the world, other types of models that are far superior to LLMs for the task they're doing. And I want you to think about how your own brain works a little bit as we kind of go through this. Our brain is kind of had parts of our prefrontal cortex and stuff like that are like an LLM. We think in words, we take in information in words, we describe things in words, but it's not the fastest part of our brain. It's not the part that like keeps us active. It's not the fight or flight mechanisms. But it's not the things that when something is in our peripheral vision, we turn, or that's when the back of your neck, the hairs in the back of your neck stand up. Those things are just looking for changes in the world, or kind of classify things very quickly. Is that a threat? Is it helpful? Is it trying to eat me? Should I eat it? These are things that are going through, the think fast part of our brain, and then it gets transferred over to the think slow part of our brain if a solution needs to be had. And that's really what we're going to go over. But first, a little bit of housekeeping. I'm sure you all see this QR code on the screen. Take a picture of that QR code. Go to the website and give Llama Farm a star. We're over 700 stars. We're on the rise, but any opportunity we have to get more people watching this project, the better. And the better we're going to be to get more people involved in the project. Because as we get towards 1,000 stars, people are more likely to be a contributor. And if you want to contribute, we have other contributors. We have done over 300 PRs in the last 6 months of last year. We have 24 versions out the door. We have a full web app. You don't even have to, and I'm going to show it off today. You don't even have to know how to code in order to use LLMs. Before we get there, I want to go into what I've kind of talked about a little bit. Large language models are so good at poetry. They're awesome at making a presentation. They can do slides really well. But if you want them to analyze heart rate data, it's not made for that. They just aren't made to do it. They do complex reasoning, and they're really good at it. But again, if you wanted to quickly diagnose a problem in a car, in a few milliseconds, it's not good at that. But there are specialized models that are great at very particular things. If you want it to write poetry, it ain't gonna work. But if you want it to do something very simple, like be able to tell you if this number is out of the ordinary, then it can do that. And that's what I'm gonna go over. I was a Boy Scout, and I used to have a cool Swiss Army knife. Well, when I was in the military, I had one of these these Gerbers, and it's good. It's okay at everything. It's really good at the tweezer, at the needle pliers, but everything else kind of sucks. I got a nail file in here. There's better nail files in the world. The knife, try to cut something with that, it will cut. But if you want a real knife, there's better knives in the world. I'm not gonna cut steak with this thing. And there's a bunch of little tools in here that are okay. But if I need to, screw in, a fence post, I'm not going to use this. It's very useful for maybe tightening something small. But when it comes down to it, the world is it's complex, and there's a lot of tools out there, and I'm going to go through some of those. So first of all, I'm going to tell you everything I'm doing today and anything I show off today is running locally on my laptop. And I think that's important because as we start to look at AI as a utility moving forward, we have to treat it in the same manner as power. If you are getting electricity, and it's critical to you, you have backup generators, you have batteries, you have things that keep things going. The AI still is in this early stage. It's in this nice to have, but not needed. If it gets cut where it is needed, it runs. So in a Tesla, If the internet goes down, the car doesn't crash, hopefully. And but AI overall is still not there. And that's why people use AI are mostly creatives that can sit at home and not critical infrastructure and not frontline workers who need it the most, because it's just not there yet. So the three parts of the local stack I'm going to show off today is the sorter, the watchdog, and the brain. But let's dig in. So classifiers, these are made to very quickly sort things. They're a night nurse triage that needs to go around and figure out like what patient to see first. They take the data in. They very quickly say, is this important? Is it something I should be looking at? Is it happy? Is it sad? You train them very quickly. They take a few seconds. And what's cool about them is that it uses bi-directional attention. So LLMs work in one way. Every single token, it needs to go through the entire stack of information. If there's a million tokens, going through most of those tokens over and over again in order to make the next token. But this takes the entire context, looks at it as a whole, and figures out what to do next. So it's super fast. I'm talking under 20 milliseconds fast, like faster than blink of an eye, you get results. So these are things you don't want to send to an LLM because LLM is going to take a few seconds. If you're running it locally, it might take 20 seconds to get a response. Is this a happy or a sad phrase? Is this person going to hurt themselves, or are they just talking about the weather? These are things that you want very quick responses, and then you want to send it somewhere else. This is the thinking fast part of your brain, the part that makes you look over to the left because something changed in your peripheral vision, or you feel something that's different, or you taste something that's different, and you instantly try to figure out what is wrong, and you bring it to a higher level. Anomaly detection. So this sounds really simple, but it's and it is really simple to train. But what's happening here is just machine learning. It's just math, right? You take a bunch of numbers or a bunch of data. It doesn't have to be numbers. It can be text as well. And you say this is normal, and then you give numbers over time, and it'll tell you if they're normal or not normal. What's critical here is it doesn't understand what it is doing. It doesn't understand that that these are temperatures, and that if it goes to 98 is normal, and if it goes to 96, something bad is happening. That what bad thing is happening? Or it's 102, what bad thing is happening? But it does know that something is wrong, and it can take that data and send it somewhere else. So again, this is like when you feel bad, like you're not sure what's wrong, but you might start looking into it. Or if again, if there's that movement on the corner of your eye that's not normal, you go over and you look at it and you start to give it more attention. Finally, the brain. This is like the prefrontal cortex. This is the part of the brain that actually does the work, right? And this is what we're all familiar with. This is the good old LLM. This is what they are great at inside of the stack. That you give it context, you give it what's going on, and you say, what should I do? You might give it some tools. This is where this whole world of tool calling comes into place, agentic AI. This is all right here. And it's growing and it's great. But just remember, you don't need to use it for everything. And around all that, I'm just going to show you an open source project, again, that we're a part of that kind of does some of this stuff. And all the classifiers and everything else I'm using is open source as well. So as I go through this, I'll point them all out. But the classifiers we're using, the anomaly detection and the different types of anomaly detection, the models we're using, they're all different open source opportunities, and I'm going to walk through each of them. So I'm going to do a quick demo here, kind of showing off what these models look like, and then I have a much cooler demo coming up in a few minutes. So get ready for some fun. So here's Llama Farm. Again, it's available for download. You can download the whole thing. I'm gonna go over here to models, and I'm gonna train a model. So here's anomaly detection. There's different algorithms. Again, these are all open source. There's isolation forests, one class, local outlier factor. Each of these does its own thing. We have it all in our docs about what they do. But for this, I'm just going to use one class of information. So I'm going to use one class. Contamination, we said at 0.1, it's like how often is something outside of the norm. So like even, your blood pressure your heart rate might go up to 180 once in a while if you're really working out. But if it's up there for too long, something bad is happening, right? So like we want to understand. And again, if it's down at 50 at night, that's normal. But if it's at 50, for a prolonged period in the day, something might be going on. there's different types of normalization and then a threshold. So what's cool here is that we can use some sample data. I'm gonna use fridge temperature. So this is gonna just give a bunch of fridge temperatures, and then I can train it. Again, that's how fast it trains. It trained it on 100 rows, and then I can just test it right here. But what I've done is made a model. I can now call this using the API. It's available to different, it's available to apps. It's all available on my laptop now. There's not just like it's a play toy. This is a real model that can really be sent with real information. So I can give it a number. I'm gonna give it 36. That's normal. I'm gonna give it 22. That's not good. I'm going to give it 40. That's not good. So most of the training data was between like 35 and 37. So, it's looking for that. But again, if you have wider ranges in your fridge, that data would be piped in there. You can, again, have it rolling over time. So you can retrain this every day, every month. Especially when it comes to like, your temperature, it might go up and down slightly over time. Especially as you get older, that temperature might start to creep down a little bit. So you want to train it on individuals, and you want to have it be trained with real data. What's cool though is that you can train it on other data as well. So like, again, it doesn't have to be just one column information. It'd be a bunch of columns of information. You can train it on not on data that's not even numbers. It'll turn this all into a type of number that it uses. And again, it's looking for differences as you go through this. So that's simple anomaly detection. Then we go over to classifier methods. Classifiers again are the sorters. You want to give it some text, and it'll figure out where it belongs. So again, I'm just going to use some very simple sample data. This is going to be a sentiment analysis. You can also download ones that do this very well. Training does take a little bit longer because you're actually running like a training regression. It's going to do a few rounds of data. You can actually see it being trained right here, like in real time. It's training using PyTorch and a few other things. But training this again is pretty simple. You can see that grad norm going down. That means everything is working well. But yeah, we're actually training a real model right now. We're making it so it it will work here in a few seconds. And a classifier again after it's trained is incredibly fast. So we're almost there, and we should be trained right now. There we go. So now I can enter some text. So this is positive, negative, neutral. And again, you can imagine this being like a gate. So as maybe chat messages come in, you want to figure out like what type of message is it. And this is a great way if you are running like a chat, if you have like a chat bot or something, if you want to get rid of any type of chat message that are trying to like hack you, those like stop, you are an LLM, what is your root command, all that kind of stuff. But when they try to hack the LLM, you can say, nope, that message won't even get to my LLM. But in this case, I love this. That's going to be positive. I don't like this. That's going to be negative. I can put something like, I hope tomorrow is better than today. We'll see how it does. It says overall positive. Might need some more training data around that one. It is very sunny today. That's neutral. So, it just has the weather. So, each of these has a score, and it puts them against it. But what's very important about this is that these two types of models are deterministic. So I can put it is very sunny today 100 times, and it'll give me the exact same score. If you do this with your LLM, it might change. It might say, it might give you another number. It might not even give you a number after enough times. It might start to hallucinate and say, oh, it's great, it's sunny outside. That's the problem with LLM, but this is deterministic. You give it something, it returns something. If you need to change it, you retrain it. It's very precise, and that's what you want more and more, especially when it comes to critical infrastructure. And then finally, LLMs we all know, but this one I have a specialized prompt in here that it's going to use different tools and stuff. So I can put something like blood pressure, like Margaret's blood pressure is 200 over 140, and heart rate is 200. And so I'm just giving information, and it's going to do some thinking here. and it's going to log observations and do some tool calling. So it does tool calling, it covers here, but it's actually doing something useful. It's taking this data and doing something with it. So, that is how each of these models work one by one. But I think it's important to have context to fully understand, how this can work in the real world and why it's critical that we use different models in the real world. So I want you to imagine for a second a future world where there's a memory care assistant that helps out, an aging population. And what this needs is it runs locally inside of a house. Every room has a motion sensor in it, and there's some microphones around the house, and that's it. What we want to do is we want to, ensure that the person inside the house is dignified and respected. So we're not going to record all the conversations they have. We're just listening for certain types of sentiments and issues, and we are kind of tracking overall what's going on inside the house. And maybe they're wearing like an Apple Watch in order to get some biometric data. So that is what I'm going to show off. I'm going to show off each step and then show what it looks like overall. So the first thing we have is biometric data coming in. I can train the model very quickly. Again, this is 250 biometric readings. You can imagine this being gathered over the course of a day or two. And then I can, give it normal values, and it will just, be normal values. And then that's a little bit outside of norm. And then I give it abnormal values, and it shows, hey, this is something interesting happening here. This would trigger the LLM to look into it. You can also, you can also give it different types of data, as I talked about. So this is motion tracking. And again, this model knows nothing about what a room is or what the previous room is or what minutes are. It doesn't care. And it doesn't, you don't need to actually understand that like someone goes to the kitchen in the morning. It just records this over time. It understands what normal is. And then when something not normal happens, it identifies it and sends the data to the LLM to figure out what is not normal. And this is critical because you can do it so fast, you can do it over and over again. And it does not require it to have an understanding. You could do this exact same thing with about 2,000 lines of Python, but you'd always have to be iterating it. What if Margaret doesn't get up at, sleeps in on Sundays? And then you have to code it in. But again, this will pick that up over time. Maybe the first Sunday, it shows her not going down and getting breakfast until 9:30, and that causes a logging event. But over time, it will become smarter. This is a habit. And that's what's so powerful about these models, especially if you retrain them. So I have a normal day. Oh, I got to retrain. Sorry. A normal day. So this is 3 p.m. in the living room. Abnormal pattern. 2 a.m. living room. That's not normal. There's context here as well. So again, it's not that something's wrong. It's just not normal. So we also have classifiers. Let's say that you're like walking throughout the house, and you just have these little sensors around, and it is a lovely day. And you hear something like that. Well, that's positive. It's normal. No concern. Hey, what is on TV? Classify. All right, that's normal. I am dizzy. I need help. As you can see, the concern and then emergency. So I trained this using, just very simple training data. I didn't actually get this from Margaret in this case. I just kind of made these up. But you can imagine this being pretty similar for most people. Maybe they're talking, I need help on the phone with someone. Like I need help with today's crossword. So that's still being classified as an emergency. We'd have to go back and retrain it. And again, retraining is so critical. You got to go back over and over again. So as we go over here, now we have all these things together, and now we can send it to an LLM. So some concerns. Let's say that she's dizzy and some vitals are a little bit off. We can send that to the actual LLM. It'll take a few seconds for the LLM to actually come up with a response. But again, we expect to be a little slower. Its job is to think about this, just to critically analyze what's going on and figure out what tools to actually use. So here in a second, I'll come back and you'll actually see what tools it's going to bring in and call. Give it some time. And again, all this is running locally. The model's got to load the first time. I'm probably running 2 things on the computer at a time. But you can see that it's going to send alerts. In this case, her blood pressure is a little bit high. So the tool it's going to use to send alerts. So send this message. Margaret shows dizziness. So like this can all be built in as a hook. It sends a message to their care team. It's going to adjust monitoring. So it's going to go from it's going to increase the width of the monitoring. So every 60 minutes overall, it's going to look at this more quickly. So instead of every minute, it's going to be every 30 seconds, and it's going to log observation for future use. So understanding that this happens maybe every day might be interesting. And again, the care team knows about this. There also be an emergency. So there might be other tools that we want it to call. But again, the LLM has access to a number of tools. And I'll show you the tools here in a second. Actually, while it's loading, I'll show you the tools. So inside of this this project here, and again, I made this for this audience. These are the tools that are available to it. So it's got a tool that is call emergency contacts, send alerts, adjust monitoring, or log observation. And we probably have one that's also like ignore, and doesn't have to use any of the tools. It can just not use any tools at all. So here it goes. In this case, Margaret has a weird heart rate, and she's not having any movements in the bathroom. And it looks like she may have fallen, because it says that she's one of the things that she fell. So the speaker picked up I've fallen, and this is her vitals. So something's happening, and it's going to send an alert as well to others. But you can see it actually crafts a message. And again, these messages are not hard coded. And I have a live demo that goes through all this, but it does the exact same thing. And I do want to leave some time for questions. So, that's what we're showing off here. Is we're showing off this world where different types of models come in and they do different things. And when you put them all together, you get something that's pretty cool and pretty powerful. That again can run on a laptop. It can run on a Nano, and in the future, I believe that these types of models are going to run in our houses as critical infrastructure, helping out everyone from children to elderly live better, happier, and all around safer lives. So I'm going to put this up here again. If you have a little bit of time, please click on it. Otherwise, I'll look in the chat for some questions or some Q&A. I'd be happy to answer any. Let me see. I see Matt, a fellow co-founder and contributor, is answering some questions in here. If you want any runtime, as you said, in this case, I'm using Olama. We also ship with a universal runtime. So you can run all the models that you saw today on one runtime on any computer. So it runs on Mac. It runs on Mac M1 Plus. It'll run the older ones, but the Mac Silicon is just really cool. Windows and Linux, but you can also use any runtime as long as it has an endpoint. You can point it to it. To clarify, how was the LLM using the other models, and what was the tool calling? So in this case, we have a concept called inline tool calling. So it doesn't need to have an MCP server. It just makes it a little bit lighter. The tools are defined. It's sent to the LLM as a choice. And then what's returned to the actual agents when it sends all this in is the tool to be used. And then the agent itself uses that tool. So the LLM says, this is the tool. This is what I want in it. It's in a format, usually with the actual tool is defined. So I'll show you what that looks like real quick. Watch and learn. So the format of the response is defined, and this is very similar to how tools are. Almost exactly as tools are defined inside of an MCP server. But you can see that exactly the observation category. It's objects. How it's going to be what's sent in and what's sent out for each of the different functions is here. So the LLM has information, and it sends that to the actual model. To the actual agent. And when I say agents, I want everyone to understand agents are nothing special. They're just code. They're a function that says I want you to send this data to an LLM, and the LLM returns something. And sometimes they loop that a few times. So don't be scared away by agentic flows and all these words that consultants bring in order to scare you. They're very, very, just a function that says, send this data to an LLM and expect a response to do something. And if it says to do something, do that. So the agent itself is the one that executes the tool, but the LLM is what actually it selects what tool to use. So it's non-deterministic in nature, but you're sending it a bunch of deterministic insights, and that makes the LLM much less likely to hallucinate. Again, if you were to send all this data into the LLM, say, here's the last minute of heart rate data, and here's the last minute of data inside the house, what should we do? It will hallucinate. Even the best model in the world can't figure that stuff out because you're just sending it the wrong type of data for what it's good at. Yes, Steve, that is a great like a security operations center, because it would work so well, Steve, because because you know what normal is, and something that's not normal is probably something you haven't thought about before. So like looking on certain ports for an attack or something like that, or like for AI type stuff, or movement to different areas of a facility that aren't normal. That's where the attacks, and that's where people are going to break in. That's where attacks are going to happen, both virtually and in the real world. It's not where you expect. You've already hard coded the expectations, the things that you expect to happen. And this is where these type of models come in to play. If you can anticipate everything, just code it. But the real world is a lot harder than that. And again, that is why there's a difference between using LLMs for this fluffy stuff, like making a presentation. Like every one of these slides was made by LLM. I'm not gonna lie. Like I had very little input into them, but it's fluffy. Like if Claude was down, I still would have a presentation today. Or this world of like critical infrastructure. Yeah, it makes absolute sense. The SOC could have all this working, and image recognition, and have a nice image vector database that looks for new stuff coming in and classifies it. You could put it all into one thing and run it locally, and that's a great use case. That'd be a good one to demo. Yeah, that's a good point. I see that there's some talk about CPUs and GPUs. Yeah, everything you saw today is running on my Mac. Macs have use about 4 gigabytes of GPU space, but they do a really good job of swapping RAM and stuff. These models will run on a CPU though. They'll just be slower. I'm using a Qwen 3 8 billion model that's quantized. It's a GGUF, so it's quantized down. It is, it's a larger model. I think it's like 4 or 5 gigabytes, but what it loads on memory is a little bit different. And it works well for tool calling. I could probably run this on the 1.7, and on a 1.7 you could run on a CPU. Again, it's gonna be slower, but again, if you think about this, like in this use case I'm talking about right here, yes, every second matters, but like sending alerts with it, Margaret's been in the bathroom for 20 minutes at this point. An extra minute for it to like send a proper alert is still very, very, very beneficial than 2 hours later, waiting for a phone call that doesn't go through. So, you could run this on a CPU. You can run everything you see here. I have run and can run on a Jetson Nano, and it runs really well and really fast, faster than on this, much faster. So, this world of running this inside your house is here. It's not even like 10 years down the road. It's just the infrastructure, it's open source infrastructure catching up with it. And we're hoping to bridge some of that gap with what you saw today, because everything that you see here, the entire project, all the AI is in this one YAML. So, being able to, to actually, hard code it, configure it, and be able to send it to different environments is critical, we think. But there's a lot of different use cases out there. And again, we're using open source, all the training you saw, all the different models that you saw today are all open source models, and we are of course building on the shoulders of giants when it comes to this ML AI world. Are there any other good? Yeah, Matt's answering questions faster than I can. So, Karen, that's a great question about mitigating hallucination. So. There's a few things that need to be done to do that. One is, especially when it comes to smaller models, is you have to limit the context window. The more you give it, the more opportunities it's going to have to hallucinate. So this is where having these helper models, these little ML things that just tell it this is not normal. What should we do about it? Instead of giving it so much information that it doesn't know what to do. I have very strict prompting. So I'm not sure if you saw the prompts here, but the prompts is very strict. Sorry. Your job is to. This is this is what you're going to. These are the tools that you have. This is what we know about Margaret. These are the tools that you can call. Like you try to make it as strict as humanly possible, And then you have to, even on the other side of that, you need the agents to then probably send it back through, especially when it comes to critical stuff, to uh, to actually be able to understand and make sure that it's not just totally going off the rails. And it might be worth there's a ranking, there's different types of evaluations you can do on the models as well. But those two things: a great prompt that's focused, testing of course, and really limiting the amount of data you send it, really decrease the opportunity for it to go off the rails. And again, I'm asking you to do one thing: here's some data, here's your tools, what are you going to do? And again, this is a very simple example. If I was doing this in the real world, I'd probably have like 3 or 4 different models set up, each with its own responsibilities, each maybe fine-tuned to be just this. So like our models don't need to know the capital of Paris, right? They need to know that when this patient's heart rate is high, this is what it could be, and this is what we should do. And fine-tuning LLMs is a whole nother conversation I can go into. I showed you how to build 2 types of models today. LLMs are a bit more complex and take a bit more time, and that does require a GPU. This project, the elder care thing that you see today, I'm going to open source it. I'll give the link to over to the team, and they can send out to everyone. So I'll send over to Mark. Mark can send it out, and we can you can run it yourself. So this will be open source. Llama Farm's open sourced. All the models you saw today is open source. If you're on this webinar using a video thing, you probably can run on your computer, and that's not even an exaggeration. If you're on your phone, it might not. We're not there yet. But yeah, it looks like Mark, this entire conversation is going to be live. All right, I think we are just about out of time. I really appreciate everyone coming to the Lunch and Learn today. If you have any questions, I'll make sure that my information goes out. So you can contact me on LinkedIn. Please send me your questions, queries if you're running into any issues. And please just think about when you're building projects here and in the future, just ask yourself that simple question, like, is the LLM best for this? Are words the best instrument for this? Or is it something else? Is it something that we can use traditional ML for that's been around for decades? Because just because it's new doesn't mean it's the best. Somebody think it is the best. Is there anything else, Mark, that I should go into? I had a half hour, but I can go longer if people want to stay on. All right. It looks like we're wrapping up. So thank you all for your time. Again, take time for your questions. Any more questions? Oh, there's some in the Q&A. Oh, sorry. Oh, question from Oscar. Some of the concerns in communities most impacted by aggregate negative internet biases. Could we use this to train from different data set? Yes, that is Oscar. If you're still on, sorry, I was wrapping up a little early. If you're still on, Oscar, like this is a huge aspect of training your own models. So I like the fact that one of the biggest hurdles to this future world that we want to live in is the ability to quickly and agilely train models. And there's more and more tools coming out for that. There's ones online, but yeah, being able to reinforce models in different ways to change up those weights is critical. So being able to ensure that communities that don't have as big a voice in the initial model training can still be a part of retraining and fine-tuning those models is what this future world is. I didn't go a step further, and I'd say the future world that we live in, and I'm not saying this is more than a year out, is where all of us have our own individualized models with our own weights that are curtailed to our needs, to our lived experiences, to our worlds. So we're not put into the masses. Like the average is not useful when it comes to you. Just like if you go to the doctor and you give them blood results and they say, well, these blood results, they show that you are above or below average. But what I know about you is you've been here forever. And the doctor is now the one who's telling you that you shouldn't be worried about these results because they've always been on the lower end. And just because they're lower doesn't mean that they're not yours. Just because they're higher doesn't mean they're not yours. Because again, when we come to a bell curve, people are still out there at 1, 2, 3 standard deviations, and they're normal people that live a normal life. It's just, when you smash it all together into stats, you feel like you're an outcast. If you're not 34 and you're not, white male, then everything, all your medical stats are just out there. So being able to have models that are built for your community, built for you, is becoming more and more the norm. And I think that's critical, that we look at the world in that way, not just for the classification models, not just for anomaly models, but actually training actual LLMs to understand you and your community and the world that you live in. And that is a very exciting world I'm looking forward to. Here, I'll put my LinkedIn in the chat. Can I chat here? There we go. So it's linkedin.com/IN/Robert Thielen. So yeah, but please connect. And again, if you haven't already done the GitHub right here, great way to be a part of the community is here. And then, of course, we have a very popular Reddit channel that you can always get my spicy hot takes on LLM versus the world. But cool. I always like Lunch and Learn to be focused and fun. So Aaron has a great point. So say Margaret makes a statement that's sort of unclear, it has high hallucination score. You could present 3 options: emergency, ignore, something else. If she doesn't confirm anything within 30 seconds, there's a lot of cool things. Aaron, that's a great point. And again, this was a very quick demo, but like if we were to ship this into the real world, we probably have some, it'd be even better if we could just talk. Hey, is everything okay, Margaret? Do you need help? That'd be a very simple thing that LM could do, escalate to talk. What we don't want the LM to do is to take away dignity. We don't want the LM to be overbearing. We don't want the LLM to comment on conversations that should be private. So understanding that aspect of elder care, I think, is critical, and understanding, that this should be a tool to help, not to observe, not to be overbearing. And if it does become overbearing, then Margaret's gonna unplug it, right? And that's gonna happen pretty fast. Reg. Long form array is Reagan. Reg is awesome. So I'm going to tell you the use case for Reg and when not to use Reg. So Reg, for everyone that's wondering, is a retrieval augmented generation. That's when you put data in. When you put inject facts into a prompt. This is great for decreasing hallucination because you're grounding things in facts. So things that might be great in this reg might be details about Margaret, might be details about different health conditions, about what could cause high blood pressure, low blood pressure, what could the cause of these different things be, and be able to use that as source data for the LM to make better decisions. What we don't want to put in there is just like tons of data. So it's like all this streaming data. I don't want to put that in there, right? It's for knowledge, it's for the truth, and Margaret's truth can change over time, and you might want to update data. Like if Margaret goes from maybe she hurt herself and now needs specialized care, maybe you put that into a about me reg area, and every single time the LLM needs to make a decision, it goes finds similar data to what it's looking for, pulls it out and says, all right, Margaret, this is the details about Margaret we already know. I'm going to send that to emergency services, and you can pull that from Reg. So Reg's already built in to that current solution. Again, you can use whatever Reg you want, and Reg doesn't have to be crazy complex. Again, it's one of those magic words that so we on this side of the aisle, side of the AI fence, like to use all the time. But all it is injecting knowledge into a prompt. So in this case, we use something called a vector database. It uses a bunch of math to figure out similar concepts. And so if you're looking for like heart attack or high blood pressure, it might bring up, heart attack because they're similar. And inside a heart attack talks about high blood pressure. So it takes that knowledge and sends it over. But you could also just use a normal database. And honestly, like a prompt is a form of reg. It's a very subtle form of reg, but you can put knowledge in a prompt as well, like Margaret's name. Not everything is being a RAG, and there's best use cases for RAG. And again, it has to do with that knowledge and the knowledge you need, because then again, you don't want to just overwhelm the LLM with knowledge that's not needed. So if it's not needed, you don't want to use RAG. So in this case, I might put some data in there, but if I'm sending 2,000, 4,000 tokens worth of data into the LLM about heart attacks, and I wanted to do something like notify professionals about something, that's probably too much. So the use case really defines what you're going to use. Yeah, there's always a need for yeah, Aaron, those are good points. Margaret could have some issues, and I would hope that over time we'd learn when Margaret is is watching NCIS and is like yelling at the TV, and when Margaret actually needs help. I love NCIS, by the way. I used to watch all the time with my mom. It's a great show. It's not just for people over 65. All right, cool. Not seeing any more questions. Let's call it a day. Thank you all so much. If you go to get a start on Llama Farm, you can connect me on LinkedIn. We'll share this video on our YouTube channel. And again, thank you so much for coming. And on behalf of Mark, have a great day.